Hello everyone, video 2 of module 4. In this video we talk about how to define load patterns. To define loads we need to start with load pattern. Load pattern is either here in this menu or you can come to define and go to load pattern. In SAP we have load pattern, load cases and load combinations. I will explain the difference between them. So let's start with load patterns. By default that is always here. What you need to do, you need to put the name of the load pattern you want, dead, live, earthquake, wind, whatever, and then you need to choose the type of the load here, and then if there is any self-weight multiplier. So for the first load pattern, always I prefer self-weight myself. It's up to you guys, but I try to always separate self-weight of other gravity loads. So self-weight multiplier is 1, type is dead, and I need to put modify load pattern to change this one. Then the next one is superimposed dead load. Type is dead, but self-weight multiplier is 0, so I need to add new load pattern. The next one is wall load, so I can put wall just to avoid of any confusion between wind and wall load. So put wall, dead, multiplier, again add, and I will put here soil pressure that I have. So soil pressure is not dead, actually it's kind of other, so I can put other and add. Also, let's just to show you how to use it, I will put water pressure as well. So type is other, add. I'm just trying to define type of loads generally we use, then it's up to you. It depends on the variety of loads you have in your actual structure you can define. The other thing I would like to prepare here is wall load for earthquake. I will explain you what it means, but just let me put wall-eq. I will explain you what is that for. So I add, and then I'm going to live. So we have live load. So for live load we have two different type of live load. One is the live load applying to other levels, and one is roof line. I will currently put all of them in live load just to actually simplify the loading and modeling. So I will put add a new load pattern, and the other thing I would like to use is thermal. So I would put thermal load. This is, if I come to more, I can see if there is any category. Yeah, it's temperature, so I can choose temperature, add new, and displacement is the other type of load I want to show you. So displacement here we can just consider it as other, and again add. So let's put a snow other here, we put a snow, add new load pattern. Okay, now we need to add earthquake and wind load. So when we define earthquake loads, so I will press OK. First explain you a little bit about earthquake and wind, that how we can apply them. If I come to a plan here, here for example, when we have earthquake load, we need to consider that we have earthquake load in both directions. So simply we can show it in combination by plus or minus. So we don't need to define two different directions for earthquake, just one direction is okay. But what is important is accidental eccentricity, which is a difference between center of mass and center of stiffness for each floor. This is about 10% of the dimension of the building normal to the earthquake. So when we have, for example, earthquake in X direction, the eccentricity could be in positive Y direction or negative Y direction. This is my own method, you don't have to follow it. What I do, I always put P and N to apply this positive and negative direction separately. Likewise for earthquake in y direction. So P and N in my definition doesn't mean that in positive and negative direction is actually positive and negative eccentricity, but you guys can choose whatever you like. I'm just adding based on this method. It's really up to you what you would like to do. So EQXP, that means earthquake X with positive eccentricity. The type is quake, and here you have quite few options. You can choose different standards and add parameters, or you can use user load or user coefficient. So currently I'm just putting on user coefficient. In the next video I will go through more detail how to actually define your earthquake load. So I will add a new load pattern, and now I can choose a copy of load pattern, and then it coming here as XP1 I can simply change it to N and mention modify lateral load. So you see that when I'm here, this modified lateral load pattern is deactivated. When I'm coming here, I can see modified lateral load pattern is changed. What we need to do when we come here and change any of them, we need to click on this to change this auto lateral load pattern if we want to use it. So EQXP, EQXN, the next one is EQYP, add, and EQYN, add. So we have earthquake loads in X and Y direction in positive and negative with positive and negative eccentricity. Now about wind. Wind is a different story, because when you have wind load, you have windward and leeward. For example, if the wind is in X direction, you have windward load and leeward load. They have different pressure, so the values of windward and leeward are not similar. That means you cannot simply put plus and minus like earthquake and say, okay, it's in X positive direction or X negative direction. Literally, you have different wind pressure. We need to define wind for positive and negative direction of X, and likewise for Y. So what I will do, I will add here wind XP, and when I say wind XP, here this P for me is in positive direction of X. So again guys, it's up to you how you want to define it. I need to come here to wind, and again I have access to different standards. I leave it by now. I'm coming to user define, and then I will add new load pattern wind XP and wind XN, add new load pattern, then wind YP and wind YN, add new load pattern. Look, there are different wind loads you need to consider in your analysis. Roof wind load, internal wind pressure, is not just windward and leeward. So you really need to check your local standard and see what are the requirements, and according to that you can complete your wind loading and also load combinations, and then complete your analysis. We will go through the details in our workshops, but I will leave it as it is by now, just to keep things simple. And I just tidy up a little bit this model, and we will continue for completion of our load patterns for earthquake and wind load. Okay, now we want to complete the lateral load pattern for earthquake and wind. But before completing lateral load for earthquake, we need to define our mass source and diaphragms. So when you have a slab or any kind of rigid diaphragm, you need to constrain all joints together laterally. It doesn't have to be, but if you want to use earthquake load and if you want to move your center of mass, you need to define it. Otherwise, SAP simply lump all masses based on tributary area for each joint separately and individually, and put all of them, and you don't have a center of mass, so you wouldn't be able to play with the accidental eccentricity. Yes, you need such a arrangement for example, light roof like this, but for the rigid diaphragm concrete slabs, you need to have a center of mass to meet the requirements of standards. So let's start with mass source. So mass source, there is an icon here, define mass source, or you can come here and use define mass source here. So you need to add what is required to participate in earthquake load. So some load don't need to be here, but some loads you need to put some factors, for example, or do some other modification. So it's up to you what is the name you want to use. Generally, I leave it as it is. It's not very important. Then I'm coming to modify show and start adding the loads I want. So here mention element self mass and additional masses. Sometimes you assign mass to all joints yourself manually. In that case, you need to leave it as it is, and the self weight automatically will be considered. So element self mass and additional masses, if you want to define the load pattern, because you can put self weight here, you don't need to click here, otherwise it would be duplicated. So either you shouldn't put self weight here, or you should untick this one and just keep the load pattern, and then you can add self weight yourself, and then superimpose dead load, add wall load, yes, add, and wall load EQ, I will explain you what is that for, add it. And then live load depends on the standards. Here is about 30%, depends again on type of the live load. If it's a storage or water tank, it's 60%. In Australia, if it's normal live load, it's 30%. So I will consider 30% and add, and the rest of loads, nothing special for me. So water is the water pressure, is not a kind of water container or water tank I have. If I have, I need to put here with factor 0.6. So that's multipliers are for my mass source. I press OK and it's set. Now we need to define the diaphragm. To do that, we're coming here and define joint constraint, and here we need to choose what type of constraint we want to apply for each level of a slab. So there are different types. You can see here we need to choose diaphragm. Here we mention add new constraint. There are a few options here, so you can mention what is the constraint axis. For diaphragm, because we want to keep all x and y axis together, we need to click on z axis. So that means we have the wording here, probably it doesn't mean that you are constraining z deflections. So in x and y deflection, they are actually constrained and they're moving together, but in z direction they have different deflection or different displacements. The other option you have, you can go for rigid diaphragm, which is this. If you don't want to use rigid diaphragm, you can press that semi-rigid diaphragm. This is good because sometimes you have some walls or other vertical elements which are not aligned with elements below, and you want to see the effect of transferring lateral load from one vertical to the other one below, and that part should be absorbed by a slab. If you go for rigid diaphragm, because all displacements are actually constrained together and they are moving together, you don't see any internal force in a slab. But if you use semi-rigid, then you can see internal force in a slab. So in this case, for the project we have, I will use semi-rigid for that 160 slab, and I will use rigid diaphragm for lower levels, just for practice. It's really back to my adjustment. My preference is always using semi-rigid. The other thing you can use is assign different diaphragm constraint to each different selected Z level. If you don't do that, literally you have one rigid diaphragm for all levels, which is not correct. You need to assign them separately. If you want to choose different type of diaphragm, for example, I want to choose semi-rigid for this level but rigid for below levels, I am not able to choose this one. But when I doing this, literally it gives me for all levels from here to top, actually this flexibility that I have different diaphragm. Whatever I need is from Z0, which is my ground level, I need a rigid diaphragm. So actually I just need it for 4 levels. So to manage what I want to do, I will go for diaphragm 1, 2 and 3 and 4. So I define them separately. I'm not using this option. So this is diaphragm 1, z-axis, okay. Then I will add another constraint, diaphragm 2, z-axis, okay. New constraint, diaphragm 3, z-axis, okay. And the last one, diaphragm 4, I will choose that semi-rigid. And the other option was just using semi-rigid and click on this, and then I can assign diaphragm at each level I want. So that gives me the flexibility to use just one diaphragm for all levels. So let's move on. So we have 4 different diaphragms now. I press OK. I'm coming to, I can start from here, it doesn't matter. So top level, I select all joints. You just need to consider this, that if any joint is not connected to the slabs, for example, you have a stair here and there are some joints here for some reason that, for example, extension of the wall coming inside the stair void, and that wall is not connected to the slab, you need to manually deselect them. SAP doesn't understand. In ETABS there is an option that checking diaphragm from shell element, but in SAP we don't have it. So you need to manually deselect any joint that is not connected to slabs. In that case, SAP assign the mass separately to that joint. Now I need to come to assign and come to joints, and here I'm coming to joint constraint, and here I'm choosing diaphragm 4 for this level. Apply. Then I go one level lower, and again select all those joints here and assign it to diaphragm 3, and I will do the same for the 2 other levels I have. So this is the other Z level. You can see Z here. What is Z? Sometimes it doesn't show when you are in assigning something. The title is not of the view is not the Z level, so you need to check Z level here at the bottom right or left. So I'm choosing diaphragm 2 here, assign, and now you can see Z4 here. When I'm here, you can see XY plane as Z4 below. Now I'm going to the lower level. Actually, this level is Z0 and it's not participating in earthquake because this is my base level, but it doesn't harm anything, so I'm okay to assign diaphragm for this one as well. Okay, now I've assigned my diaphragms. I'm not doing anything for above level. When I don't assign diaphragm, what will happen is SAP is lumping mass based on the load on each element and tributary area of each joint and lump the mass at that specific joint automatically. The way mass will be calculated is based on the mass source we define. So SAP automatically add up all those loads and load factors together for each joint individually and apply the lump mass for each joint based on that tributary area.